Hello, my 11th standard warriors. How's everyone? This is Shreyas here, your physics master teacher at Vedantu going live. And welcome to the Nurture series for all the 11th standard students. And even a drop student can watch these classes. So if you're wondering what this Nurture series is, this is nothing but a long-term batch, free of cost on YouTube, which will cover all the topics of 11th standard. And similarly, we have the Pathfinder series for 12th standard. So thanks for tuning in. Thanks for coming. Hello Ishpreet. Hi Chandan. Hi Aishwarya. Thanks for all the hearts. And you know, my day and my session starts with these lovely comments and these hearts that just makes my day. Trust me on that. So welcome aboard. This is a lecture number 2 of simple harmonic motion, or just you can say oscillations. And what are we going to do in today's class? We are going to see restoring forces and what effect does it play in simple harmonic motion. Then we are going to see the differential equation of simple harmonic motion, very interesting thing. And then we'll go to the spring mass systems. Then we'll go to the energy in the SHM. And then how do we combine springs in series and parallel? And yes, we're going to have different ways of solving SHM problems, and you will be fascinated looking at those ways. And yes, we're going to have lots and lots of problems along with the homework questions, and also the students who have solved the homework questions out there, I'll be showing them to you in in a bit. Okay, so hi Deepasri. Hi, I'm very good. Aishwarya. Hello Rohit. Hi Vivek, NEET aspirant. Thank you bacha, it means a lot when you put that heart and when you say that you love us. Thank you so much Harita. Thank you so much Vivek. Hi Infan. Glad to hear that. And those of you who do not know me, I am Shreyas. I am teaching for a very long time, and I am here on YouTube to spread the joy of learning, and not just in our country but also beyond the borders. So thanks for tuning in, and also hitting the subscribe button. I am so proud that we are now a huge family of more than 78,000 students, and from all over the country and even across the borders. Thank you so much. Thank you so much. And thank you for even liking the video. It means a lot. So let's move to today's session. But also let me tell you that this year there were, so many students who made us proud. And I'm pretty sure in 2023, you are going to make me and the entire Vedantu team proud. Because this year we had 1,500 students. That's 3 times more than the previous year, who cracked the JEE Advanced examination. 6% of the entire IIT batch will be from Vedantu. That's a massive number. And so many students were just from small towns and cities. So, that's the power of online education. And right in your hands is that tool, is that superpower tool, which can enable you to get those marks. These students did not go to, some offline coaching. They were studying with us in Vedantu. So you should feel proud that you are saving time, you are saving your parents' money, and you are getting the best across the country just at your fingertips. Let's do a quick recap. Yes, Chandan. Yes. Thank you. It looks like very easy because of me. I'm so grateful. Hi Gokul. Hi Vaishal. Yes, I'll use Pandu, for sure. I'll use Pandu. Okay, Vaishal, let's use Pandu today. A quick recap. What was simple harmonic motion? It was a special case of periodic motion, and oscillatory motion is nothing but to and fro motion. There is difference between periodic and oscillatory motion, like I have mentioned before, and the time after which the motion repeats itself is called as the time period, and that's the smallest time interval. Frequency is the reciprocal of the time period, and SHM, has peculiar characteristics, like the equation of SHM comes out to be a single sine term or a cosine term, where A is the amplitude, omega is like angular frequency, how quickly it is oscillating. A tells you how much is the extent of the oscillation, the amplitude on either side. Phi tells you where it is initially when you open the eyes. So if phi is 0, it was at the mean position and going that side. So it tells you the current location, the initial location of that SHM. Acceleration is minus omega square x, or you can write it as minus a omega square sine. In fact, I had given you a trick. If position is sine, velocity is cosine, and acceleration is minus sine, because the derivative of sine is cosine, derivative of cosine is minus sine, and each time you take derivative, that omega comes outside, so that a gets multiplied with omega. Next time you take the derivative, it will become omega square. And we had also seen this equation, which was very crucial, omega root x a square minus x square, which were different equations to help us solve different problems on kinetics. Now, today let's talk about spring mass system. Let's talk about spring mass system. Hi Saja, hi Molesh, welcome aboard. So if you have missed the previous class, don't worry, you can still watch it after the session ends. And yep, even if you're joining in late, it's okay. We are just starting the session. In case you have missed it, you can still go back and watch the replay even in live class. Now, if you look at this spring mass system, there is some peculiar thing which is happening. You take a mass, you push it or pull it on one side and leave it, you will see it will go back and forth like in this animation. Why is it doing so? Observe. The blue arrow mark is the displacement. The red arrow mark is the force by the spring. For example, if the spring is extended, that means the displacement is towards your right side, it is positive, then the force will be towards the left side. The spring will try to come back to its natural length, right? Now, the moment the spring pulls it back, the mass gains momentum. It starts acquiring velocity. And the moment this mass reaches this yellow line, which is also called as the mean position or the equilibrium position, a special thing happens. When the mass comes over here, there is no extension. The displacement, the extension is zero. Check that arrow mark. But the moment the displacement becomes zero, the force also becomes zero. You can see the moment red arrow mark becomes zero, blue arrow mark also becomes zero. But that does not mean that the block stops, because the block had gained certain momentum. It had gained certain momentum, so it will use that momentum and go to the other side. And the moment it overshoots and it compresses the spring, now the spring is like, hey, wait a minute, stop there. So it tries to apply the force in the opposite direction, it stops it, and by the time it stops, the spring has already got compressed. So now the spring again goes back, it goes back to the mean position, it gains momentum, and the spring force vanishes. Spring force is like, okay, I'm done. But again, you have momentum, so again you go to the other side. And the story repeats itself, and that's why this mass oscillates, right? That's what will happen. So, we want to know, is this actually a simple harmonic motion, or is it just an oscillation? And let's try this out. Okay, so let's figure this out. Okay, so first of all, we all know, okay, whenever you have a spring mass system, the restoring force of the spring on the mass is given by F is equal to minus kx. The reason why I'm using minus this time is because I'm not just interested in the magnitude but also the direction. See, K is the spring stiffness constant, how hard it is to stretch or compress the spring. If K is more, it's very hard to stretch it. X is my displacement. In this case, if X is negative, force is positive. You can see the arrow mark. Do you see displacement is negative, force is positive. If displacement was positive, force will be negative. They are always of the opposite signs. That's why you have this negative symbol. Vignesh, it's going to be fluids. Concentrate now. Is that clear, all my warriors? Why that negative sign is there? Now, by Newton's law, let's just use by Newton's law, by Newton's laws, what can we say? We can also say that the force acting by the spring also produces some acceleration. F is equal to ma, right? Now, since the LHS is equal, how about this? I can equate the RHS. So therefore from the above two, MA is equal to minus KX. Interesting. Let's just shift M on the other side and see what do we get. A is equal to minus K by M into X. Now I'll be like, okay sir, so what? What are you trying to achieve over here? I'm not able to understand. What are you trying to do exactly? Let's just rewind back a little bit. That's why I gave you the little recap just before we started the session. Remember, for SHM, what is the acceleration? The acceleration is minus omega square x. Isn't that so? The acceleration is minus omega square x. That means if you compare this and this, I can see some resemblance. A minus minus x omega square k by m. Oh, that means the equations are similar. For a SHM, the acceleration is some constant with a negative value of x. That means here also the same thing is applicable. It just implies one simple thing. What does it imply? It implies the spring mass system. The mass and the spring system is performing. What is it performing? Is it performing a dance? Is it performing a drama? It is performing simple harmonic motion. That's what it says. And just by comparison, I just get over here omega square is k by m. If omega square is k by m, omega is root of k by m. Isn't that true? Omega is root k by m. Very, very good. So that's what it is. So understand, in my previous class, I clearly mentioned for what is the condition for SHM. So whenever you have SHM, x is a sine omega t plus phi. That's what you defined SHM to be. An equation which has only one sine term. When you differentiated it twice, you got this. That means if you integrate it twice, you will get back this. So any acceleration of this form must be SHM. So if some system has acceleration as negative some constant into x, it must be SHM, because if you try to integrate it, you will get this equation back. You're going to get this equation back. That's what it means. I hope that makes it double clear. Now, since we just got comparing omega square is k by m or omega is root k by m, I can get few more things like, look at this. Everybody remembers time period was 2 pi by omega. Do you remember this? So how about using that over here? So I'm going to get, therefore, time period is equal to 2 pi divided by root of k by m. So if I arrange it neatly, I'll get time period is equal to 2 pi under root m by k. Very interesting formula. Very, very interesting formula. So what did I just get? I just got the time period of a spring mass system whose mass is m, spring constant is k. If you tell me the mass, if you tell me k, I know how much is the time period of oscillation just by reverse calculations. That's it. So that's the time period of a simple harmonic, that's the time period of a spring mass system, and we also proved that it is SHM. That's what it is. Thank you, Aishal. Thank you so much. Hi, Supriyo Morbangan. Hi, Dayani. Welcome. Good evening. Did you guys get it? Hi, Kalyani. Long time. Yep. You're a little late, but I'm pretty sure you can catch up. Yeah. So beautiful equation. You're going to remember all these things. So what are the important things? That yes, it is SHM. Number two, the time period is 2 pi under root m by k, or you can also remember this particular expression, omega is root of k by m. One and the same thing, because you can get this from this or this from this, since time period is 2 pi by omega. So either you know time or you know omega, you can find the other. That's what it is. Perfect. So now what is this differential equation? You might be wondering. Hi, Subiksha. Yes. What is this differential equation? You all have heard about equations. You're like, sir, what the hell is differential equation? Okay, let's solve some easy questions. Imagine I give you 2x minus 4 is equal to 0. Therefore, x is equal to, come on, let's see how many of you are smart. Come on. 2x minus 4 is equal to 0. So x is equal to how much? Very easy peasy lemon squeezy question. Come on, my warriors, quickly fill up the chat box. Spam the chat box. What's the answer? 2. Perfect. Perfect. Very good. Now, if I tell you x minus 1 into x minus 3 is equal to 0, therefore x is equal to how much? Spam the chat box quickly. Good evening, good and Bolgar. Come on, spam the chat box. X minus 1 into x minus 3 is equal to 0. It's a quadratic equation. This was, by the way, a linear equation. This is nothing but a quadratic equation. So obviously x is equal to 1 or x is equal to 3. Perfect. 1 or 3 looks like my janta, looks like my minions, looks like my warriors are very smart. Now you get the idea that linear equation has one solution, quadratic equation has two solutions, a third order equation might have 3 solutions, and so on and so forth. Now imagine this. Just imagine this. I give you another equation. 2 dx by dt, 2 times dx by dt minus 4 is equal to 0. This is not a linear equation. This is a differential linear equation because there is some derivative term. Now you will be like pulling your ears and hair like, oh my god, what the hell is this? Guys, it's very easy. Just take the 4 on the other side. So this will become dx by dt is equal to 4. Here you have that 2. Cancel it, it will become 2. Over here, shift the dt on the other side. So dx will become 2 times of dt. Now what are you going to do? Are you just going to stare at it? Obviously not. You're going to integrate it. Because that's your tool. So integrate it on both sides. But what are the limits? Well, I don't know. So when you don't know the limits, what do? Well, indefinite integration. So what does it have? A constant of integration. So integration of dx, what is integration of dx? It's x. Integration of time, that's 2 t. Okay, and you will have a constant. The interesting thing to note over here, is that a differential equation, the solution of a differential equation is not a number. Try and recollect, just before this, 2x minus 4 was 0. The solution of this equation was x is equal to 2, which was a number. This is not a number, this is a function. Do you see that? This is nothing but a function. So my point is that for a differential equation, what you would expect the solution to be, not a number, but a function. That's what it is. Yep. So any differential equation, when solved, you will most likely not get a number, you will get a function of something. That's what it is. Understoodo? Clearo? Amazingo? Likingo? Please let me know. So why there is no constant on the left side? Well, Molesh, even if you add C1 and C2, when you shift C1 to the other side, C1 minus C2 or C1 plus C2 will again become a new constant. So why do you want two constants? You should just club it into one single constant. Fair enough. Now you'll be like, okay, so now what? Here it is. Observe. From the previous slide. Okay, so from the previous slide, what did we just get? F is equal to MA and F is equal to minus KX. Therefore, we got MA is equal to minus KX. Shifting it on the other side, I'll get MA plus KX is equal to 0. Acceleration is the derivative of velocity. Velocity is the derivative of position. Hence, acceleration is the double derivative of position. So hence, what does it mean? M into the second derivative of position plus Kx is equal to 0. What does this look like to you? What does this look like to you? Come on, my warriors, please let me know. Think. No problem. Oh, Krishna Akami, I will definitely try responding to you on my Instagram handle if you have messaged me. Yes, I'll definitely get back to you. Okay, so what does this look like to you? Is this equation looking like something to you? What is this equation looking like? Is it not a differential equation? Definitely, it's a differential equation of simple harmonic motion. What does a differential equation have when solved? It has a solution. So when you have to solve it, it has a solution. And what is the solution? The solution is a function, and this function x is already known to you. It's already known to you. What is that function? X is a sine omega t plus phi. So that's the solution of this, where omega is nothing but root of k over m. We just got it, right? Omega is root k over m. So that's the solution of this equation. Perfecto. Perfecto. So that's what it is. Now let me give you a brief example just to make you understand what I'm exactly talking about. Okay, so then you'll get a hang of it. Okay, so anyways, just a brief roundup of what and all we saw. Time period was 2 by under root m by k. Frequency will be 1 by time period. Omega was root of k by m. So that's what we saw. So I'll just give you a simple example on the board. So follow me closely. Imagine I tell you 7 second derivative of x with respect to time plus 3x is equal to 0. Do you see that this is very much similar to m second derivative of x with respect to time plus kx is equal to 0? Can you see that? It is very much comparable. So definitely this is nothing but the differential equation of SHM. So if somebody asks you what is omega, what is the angular frequency of this oscillation, what will you do? Root of k by m. So what is k over here? K is 3. What is m? That is 7. So that is omega. If somebody asks you what is the time period, you will be like 2 pi under root m by k. What is m? 7. Compare. M is 7. What is k? K is 3. That's the time period. That's it. Yep. That's all. Yeah? Did you guys get it now? How differential equations work? So if differential equation is given to you, you automatically know just by comparison that what is omega and what is time period and anything else that you want to know. So even if you want to find x will be some a sine omega. Omega was root of 3 by 7 into t plus phi. So that's the solution of this. As simple as that. Ganesh, not as of now, but I'm taking lots of micro courses. So yes, you will find me in micro courses of Vedantu Pro subscription. So let's solve problems. Then you will start getting a hang of it. Here is the first question coming up on your screen. The equation of motion of a particle in SHM is a plus 64 pi square x is equal to 0. In the equation, a is the linear acceleration, okay, of the particle at displacement x. The time period of SHM in seconds is how much? That's the question. Come on, my warriors, think about it. What do you think should be the time period? I'll just give you probably a minute. Okay, just 1 second. Yep, let me just start the timer. Yep, not more than a minute. Starting now. Figure this out. Options are in front of you. You just have to use your boards, your rough notebook. That's it. Come on, start scribbling and figure out what do you think the answer should be. Okay, yes, Remo, join in. You're a little bit late. You missed the differential equation and time period part, but quickly rewind back and catch up at 2x speed. Everybody's waiting for you. Okay, let's see how many of you can get this quickly. Acceleration plus 64 pi square x is 0. X is the displacement. What do you think should be the time period? Come on, figure this out. Okay, hardly 15 more seconds to go. Okay, come on, my warriors. Let's see how many of you can get this. Oh, is it that difficult? Is it that difficult? Okay, Chandan says 1 by 4 and the time is going to be up very soon. Time is going to be up very soon. Okay, let's try to get this question. First of all, since acceleration is given to be this, so therefore acceleration will be minus 64 pi square x. Acceleration will be, if you shift it to the other side, minus 64 pi square x. But do you remember, acceleration is also minus omega square x for simple harmonic motion. Do you remember that? So just by comparison, you can see what's happening over here. You can clearly see that omega square is 64 pi square. Therefore, omega is nothing but 8 pi. And you also know time period is 2 pi divided by omega, right? So therefore the time period should be 2 pi divided by omega. Omega is nothing but 8 pi. Therefore, the time should be 1/4 of a second. So which is option A? Done, done. Got it? Yes, Vivek. Yes, Molesh. Looks like some of you got it now. Very good, Roshni. All right. Very good. Chalo, let's get moving to the next one. Hi, Srishti. Join in, bacha. Okay. Let's move on to the next one. There is a mass which is attached to a spring. It oscillates every 2 seconds. You add more mass and increase it by 2 kg. Then the new time period increases by 1 second as compared to the previous one. How much do you think the original mass should be? Don't worry, that happens sometimes. And that's the reason why you are here attending my classes, so that you get to know what's wrong and what's correct and brush up on your concepts. Let's do the next question. Now, it's mentioned that the original mass makes the spring mass system oscillate every 2 seconds. So we all know for a spring mass oscillating system, the time period is given by 2 pi under root m by k. The time period in this case is 2 seconds. So this is 2 pi under root m by k, of course. Now, here is the next catch. If you increase the mass by 2 kg, when the mass, the new mass, is the previous mass plus 2 kg, the time period increases. The time period. What is the new time period? It increases by 1 second. The previous time period was 2, so 2 plus 1, which is nothing but 3 seconds. So, if I again use this formula, the time period is 3. Here I have 2 pi under root, instead of m, I have m plus 2 divided by k. So, let's divide these two. Okay, so let's divide these two and see what do you get. Divide 2 with 3. So 2 divided by 3. 2 pi and 2 pi will cancel. K and k will cancel. I will just have root of m by m plus 2. Square both sides. So you square both sides. So what do you get? You will get 4 by 9 is equal to m divided by m plus 2. Right? Cross multiply. So 4m plus 8 is equal to 9m. Correct? So therefore 8 is equal to 5m. That means m is equal to 8 divided by 5. 8 by 5 is nothing but 1.6 kg. That's it. That's the answer. See if you guys got it. See if you warriors have understood this question. It's a direct application of this formula. Time period is 2 pi under root m by k. Initially the time was 2 seconds, mass was m. When the time period becomes 3, the mass is m plus 2. So I divided this with this. So k, 2 pi got cancelled. And just solving the basic maths, you get it. Perfect. Let's move on to the next one. Okay, perfect. Yes, the answer is 1.6 kg. Now let's go to energy of SHM. But also, I would like to show you how many of you have solved the previous homework. And I'm pretty sure there are lots and lots of comments out there. So let's quickly go to the previous video before proceeding ahead. This was lecture number 1. That's where you find my lecture. And all you need to do is make sure the time I give you the homework, make sure you solve it and post it immediately after the class ends. So very good, Ishpreet, and you have enjoyed the session. Let me just like this comment. And okay, and some of you have doubts. I will definitely get back to you. So I will just put up a like. I'll put up the heart as soon as I reply to your comment. And well, good Roshni, very good Harita. And thank you Aishwarya for liking it and for that lovely heart and that answer out there. Very good Suchi Mama, very good Raghu very good. Arun has enjoyed the session. Thank you Chandan, thank you Saja. And I have whichever chapters I have finished, it's all there in the past videos. Sylvia, Catherine, okay, it's all there. You can just go to the past videos. I'll just show that to you while going back. Okay, very good Gokulnath, very good Harshal. Very good. I'll just reply to all these comments later on. Thank you, Arun, for that heart and for solving the homework. So all you need to do is just go to the playlist. So when you are watching this video, just go to the playlist. You will see all my past videos out here. You can see that. Okay, nurture series. You can see it right over here. So keep posting the answers. Yep, as soon as I give the homework. Okay, now let's move on. What's the energy of SHM? See, a spring mass oscillating system, the mass possesses kinetic energy. The spring stretches, compresses, so it possesses potential energy. So let's find both of them out. So if I talk about the potential energy of the spring, then that potential energy U will be just half k x square. And we all know that the value of x is nothing but a sine omega t. So if I substitute that, it will become a square sine square omega t plus phi. Okay, so if you want to put that phi, that's okay. So that's what potential energy function looks like. So now that I know, if I've been given the value of x, I can find u. If I've been given the value of time, then I can find out u, which is the potential energy. So either I should know x or time to find the instantaneous potential energy. Now let's do the next part. Imagine I want to find the kinetic energy of the mass. Okay, the kinetic energy of the mass. So obviously kinetic energy is half mv square, and we all know what is the function of velocity. It's a omega cos omega t plus phi. So squaring it, it will become a square omega square cos square omega t plus phi. Isn't that true? Now I'll do one small thing. Remember, just some time back I told you omega is root of k by m. Square it, it will become omega square is k by m. Shift it to the other side, m omega square will become k. The reason why I did it is because I have m over here and omega square over here. So m into omega square is actually k. So to bring it into this form, you will see what I have done. M into omega square is nothing but k, and this is nothing but a square, and I have cos square omega t plus phi. So that's the value of your kinetic energy. So kinetic energy will become this, which is cosine square function, and potential energy will become a sine square function. Now the last step will be to basically add both of them. So the total energy of the spring mass system, okay, so the total energy, which will be potential energy plus kinetic energy. I want you to think mentally what happens. I want you to think what happens. Oh, did I by mistake? Oh, Chandan, my bad. Thank you for reminding me. I'll definitely like it by mistake. Yeah, my bad. Okay, so what will happen? E will become u plus k. Just add them. Half k square is constant. Half, okay, just half k a square is constant. In brackets you have sine square something plus cos square something. What is sine square plus cos square, my warriors? What's the value of sine square plus cos square? It's a trigonometrical identity. It's nothing but 1. So the total energy will just become half k a square. So a lot of important things that you are learning out here. So the total energy of SHM is half k a square, and it is a constant. It makes sense. When you are fully extended, then it is only potential energy. There is no kinetic energy. Then that potential energy gets converted into kinetic, and you have maximum energy at the center. There is no potential energy. And then again that kinetic goes into potential, and again that potential goes into kinetic. So there is conversion of the forms of energy, but the total amount of energy remains constant. That's what you get to know from here. Half k constant, which is the spring constant, into amplitude square. So you got to know the spring potential energy formula. You also know the kinetic energy formula. If one is a sine square term, the other one is a cosine square term. So you can also see one more interesting thing right over here. What do you think this half k square term is? This is nothing but the max potential energy. Remember, there will be a moment when this term will become 1 and the potential energy will be the total energy. Can you quickly identify where will that be? There will be a time when this sine term or sine square term will become 1 and the potential energy will become this value, which is the total energy. When do you think the potential energy becomes the value of total energy? That will happen at mean or extreme. Where will it happen? Come on, think about it, my warriors. Where do you think the total energy and the potential energy will be equal? No, it will not happen at the mean, it will happen at the extreme. Hi Kunj. Yes, maximum stretching or maximum compression, both the places, both the extremes. So all the energy is in the form of potential energy, there is zero kinetic energy. That's what it is. So this is maximum potential energy. Same way, there will be a time when this cosine square term will become 1 and this is nothing but going to be the max kinetic energy. Where do you think the total kinetic energy will be equal to the total energy? Where do you think the kinetic energy will be equal to the total energy? Come on, think about it. This will happen at the mean position. Yes, this will happen at the mean position because it will go with maximum speed at the mean position. Okay, and that's what you can see over here. Potential energy is maximum at the extreme. Kinetic energy is maximum at the mean position. Very, very important. No Molish. At extreme, stretching is maximum, so potential energy is maximum. At the mean, stretching is 0, so potential energy is minimum, but kinetic energy, because maximum speed occurs at the center, so that's when you have maximum kinetic energy. Understood? Clear? All my warriors? Fair enough? Okay, let me show you a graph before going ahead. So we have potential energy formula, we have kinetic energy formula all over here. Okay, so you need to remember those things. How would the graph of potential energy and kinetic energy look like? Well, think carefully. How do you think the graph of potential energy and kinetic energy look like? Well, potential energy was half k x square. X square, parabola, x square, parabola, quadratic equation. And total energy is constant, so it should be a straight line, correct? Total energy should be a straight line, potential energy should be a parabola, U-shaped. And what about kinetic energy? Well, potential energy plus kinetic energy is total energy. So when potential energy is more, kinetic energy is less, and when potential energy is less, kinetic energy is more. So it will be exactly opposite of potential energy. It will be exactly opposite of potential energy, correct? So whenever this is maximum, this is minimum, and this is minimum, that is maximum. So it should look something like this, and it perfectly correlates with this graph and this oscillation. Look at this. K is that pink line, kinetic energy. The potential energy is that blue line. So when it is completely compressed, you can see that the potential energy is maximum, kinetic energy is minimum. When it reaches this point, it has maximum kinetic energy, potential energy is minimum. And when it reaches the other side, kinetic energy is minimum, potential energy is again maximum at the maximum stretching. Yes, Santwana, we are going to solve mechanical properties of matter as an independent chapter very soon, don't worry. Yep. Yes, Abhinav, definitely. And in fact, Abhinav, let me tell you, there is a special derivation course which I have conducted for all the derivations of 11th standard. Right from vectors till waves, all derivations. It's a modular course, free of cost for all the pro users. So if you are in Vedantu Pro, please make sure you search for derivations of physics 11th standard, you will get it. Let's start solving the questions. For a particle executing SHM, the kinetic energy K is given by K naught sine square omega t. The maximum value of the potential energy is how much? Come on, this is an easy one. It should be done within 20 seconds. Very easy. Abhinav, just leave a comment after the video ends. I will ping you what you should search for in the Vedantu Pro subscription. So if you are in the platform or Vedantu platform on our app or on the website, there is an option called as enroll into more courses. If you are in the part of the subscription, just search for my course derivations. That's it, you'll get it. Okay. No, Litesh, I have not yet done mechanical properties of solid. I will do it very soon. Yep, I'm going to do it after SHM. Yeah, that's the next few chapters. Ankit, all the best. Don't worry, there is a special video coming up for all the 12th standard warriors and even the 11th standard warriors in just some time. I just shot a video. I'm going to put it up right after this video ends. Okay, I have to edit it and I'll just put it. Okay. So Saja, if you're not a math student, yes, definitely this chapter will be difficult for sure. Okay, so especially if you're a NEET student, definitely this is going to be a little bit painful chapter, but if you follow my lectures and if you put in a little bit of effort, trust me, it will become easy after some time. Okay, so correct answer is actually K naught, and the reason for that is here this K naught is basically the max K, which is also the total energy, which is also going to be equal to the max potential energy at some or the other point. So obviously the maximum potential energy should also be equal to K naught. As simple as that. Done. Option A. Next question. Let's see this. A particle is vibrating in SHM with an amplitude of 8 centimeters. At what displacement from the equilibrium do you think it has half potential and half kinetic energy? Let's see. How many of you can do this? A particle is vibrating with SHM of amplitude 8. At what position do you think half of its energy will be potential and half will be kinetic? Exactly equal distribution. Yes. At mean position, the potential energy is 0. Yes, Harita, in spring mass system. But otherwise, it would be minimum because potential energy can be arbitrarily chosen as 0 anywhere. So saying that it is 0 is wrong. Saying it is minimum is a better word. Okay, because you can choose anything as 0 energy for potential. All right, let's do this question. So we have the amplitude as 8. We have the displacement where we need to know the displacement when potential energy is equal to kinetic energy. If these two are equal, then it also means the potential energy is half of the total energy. Correct? Because potential and kinetic are equal, potential will be exactly half of the total will be potential. Therefore, using the formula, potential energy formula is half K x square, okay, is equal to half of this energy. The total energy is half K A square. Don't get confused, this is actually kinetic energy, by the way. Now I can see so many things get cancelled. This half, this K, this K. So what am I left with? I'm just left with x square is equal to A square by 2. Therefore, x is equal to A by root 2. Therefore, substituting x is equal to 8 by root 2. Rationalizing, I'll get 4 root 2 centimeters. So is that there? Yep, it is there, 4 root 2 centimeters. Done. Okay, looks like all of your midterm examinations are starting. Oh, so 11th standard warriors, is your midterm starting? What is it like? Yeah, I can see little bit less students today. Have your midterm exam started, or do you have some vacations, or what is it? What is mechanical energy? It's the sum of potential and kinetic energy. So when you add them up, the total energy is called as the mechanical energy. Is that the name of system of particles and rotation? Yes, Ashin Shibu, that's exactly correct. Exactly. In NCERT, Ashin, system of particles and rotational motion includes center of mass, momentum, and even rotational motion. But in JEE books, if you open DC Pandey or even HC Verma or Sengage and all these books, you will see rotational motion is separate, center of mass is generally separate, and then momentum collisions is separate. So that's how it is. Thank you, Ram Prasanna, for all the love. Moving on to the next question coming up on your screen. There is a mass of 1 kg. It executes SHM, displacement is something, and it is given by this equation. How much do you think is the maximum kinetic energy? What do you think is the maximum kinetic energy? Let's try to figure this out. Okay, Gokulnath, so you have your midterm. What about others? Please let me know. How is it going for you guys? So we need to find the maximum kinetic energy. So max kinetic energy will be obviously the total energy of that system. And what's the total energy of that system? It's going to be half K A square. But I do not know the value of K, but I know something else. Remember this, omega is the root of K by M, and when you square it, so from this you get K is equal to M omega square. So how about using that over here? Because I know the mass and I think I can find out omega also. So if you substitute, you will get M omega square A square. Now observe carefully over here. See, this 6 is nothing but A. So A is 6. This 10 is nothing but omega. And this is nothing but mass. So substituting these values, what will I get? Half into mass, which is 1, into omega, which is 10 square, into amplitude. Amplitude is nothing but 6 square. So this will be half into 100 into 36, which is 100 into 18, which is 1800 joules. And I think B answer should be correct. Perfecto. I hope this is clear. Understood? Yes, Chandan, it is B. Deepak, even if you are a NEET student, you can watch it here. There is no difference. Yes, Ganesh, it's going to be the same thing. Yep. All right. So, just the questions could be a little bit more difficult, obviously. But it's always better to be over-prepared than obviously under-prepared. Okay. So, the force on a body is 2 Newton when the displacement is 2 centimeter. So, there is a body which probably is executing SHM and the force is 2 Newton when the instantaneous displacement is 2, amplitude is 10. So, obviously the amplitude is going to be much larger. The instantaneous displacement is 2. What is the total energy with the SHM? Let's try to visualize this. What's exactly happening? Then probably we'll start solving it. So this is the line of SHM. This is my x equals to 0 or mean position. And this is my extreme position. This is also another extreme position. So the instantaneous displacement when it is 2 centimeters, then the force acting on it is 2 Newton. Obviously the force is always opposite. So there is 2 Newton force, and the amplitude. So the amplitude is the entire thing over here. Amplitude is basically 10 centimeters. That's what I get. So let's try to solve this question. From this piece of information, I think I can find out spring constant. How? Because F is equal to magnitude wise Kx. Magnitude wise. So 2 will be K into X. X is 2 centimeter. So 10 to the power minus 2. Therefore 2 goes. K will be 10 to the power 2, which is Newton per meter. Great. Now my next step is to find out total energy. Total energy is half K amplitude square. That's it. I think I know what to do next. Half into K. K is nothing but 10 to the power 2. Amplitude is 10 centimeter. That is 0.1 meter square. 10 square into 0.1 square, that's 1. So it's just going to be half. That means it's going to be 0.5 joules. Done. Got it? Yes, so if you have some doubt, please leave it in the comment section below. Definitely I'll help you out with it if you have some specific doubt. Yes, Chandan, yes, Roshni, yes, Harita. So I'm pretty sure now you're getting the hang of how to solve energy questions of SHM. It's not that difficult. Now, let's talk about combining springs together. Yep, just like you can combine resistors, you can also combine springs, and you can replace the 2 springs with 1 spring. Like look at these 2 springs. Look at these 2 springs, K1 and K2. If you want, you can replace both the springs with 1 spring. But before doing that, tell me one thing. If this is constant K1, this is constant K2, when I pull this block, do you think both the springs will extend by same amount or different amount? Quickly let me know in the chat box. Definitely, Lalitesh, I'm so glad you are inspired, and I'm hoping that you're going to make us proud very soon when you're going to write the JEE exam. Waiting for that day. Okay, Harita saying different. Hi, Thiru. Okay, Yes, yes, like I mentioned, please mention it in the comment section after the video ends below. Okay, yes, it will be different. Correcto. It will be different. No, Madan, it will not be same. Now, the reason why it will be different is, think of this like a string which is continuous. It's like a string. So, the tension, which is basically the spring force, or rather the spring forces in this one or this one, is same. The spring forces is same in this one or this one. So technically speaking, spring force in 1 is equal to spring force in 2, and if this spring extends by x1, this spring extends by x2, what you're going to see is F1 is K1 x1, F2 will be K2 x2. So if K's are different, x1 and x2 will be different. If the springs are identical, yes, then the springs extensions will be same. Did you guys now get it? Okay, because it is the same, you can think of like it like a same string which is wound, continues, again wound and again continues. So the tension throughout the spring system will be the same. Hence K1 x1 will be K2 x2. So if K1 is different than K2, x1 will be also different than x2. Perfect. Now, going ahead, you can combine both of them into one single system, and I'll tell you what the method is. Well, the derivation starts right over here only. I mean, you can just say that if I replace it with a spring of constant Ks, then the total extension will be x1 plus x2. Think about it. This spring extends by x1. That spring extends by x2. So the total extension in the total spring will be x1 plus x2. Makes sense? Hence, can I say that the x1 from here, think about it, x1 from here is nothing but, you know, F1 by K1. Think about it. X1 right from here is nothing but, because F1 is equal to K1 x1, it's nothing but F1 by K1. And what is x2? x2 is nothing but F2 by K2. Think about it. It's F2 by K2. Everybody gets this? Fair enough? Simple. Now, this will be equal to the total extension x of that spring. That's what I have just got. The total extension is x1 plus x2. x1 is F1 by K1, x2 is F2 by K2. So, what is x? X is that force in that spring, equivalent spring, and divided by the equivalent spring constant. So, here I have F1 by K1 and here I have F2 by K2. This is for that equivalent spring, on that equivalent spring. Now, do you see one interesting thing? The forces are same. So, all the F's get cancelled and I am just left with 1 by K1 plus 1 by K2 is equal to 1 by Ks. So, this is the equivalent spring constant. So, when springs are in series, use the formula for resistors in parallel, you will get the equivalent spring constant. The forces remain the same. The spring extensions add up. Spring extension 1 plus spring extension 2 is the total extension. That's how you get the answer. Is that clear, my warriors? Okay. So when springs are in series, remember 1 by Ks is equal to 1 by K1 plus 1 by K2. As simple as that. Alright. Now in parallel combination, basically you have two springs, one beside the other. One is here, one is there. And when you pull that system, what will be same? Their extensions will be same. This will also extend, that will also extend by the same amount. Their extensions will be same. What will be different is the force. The force will be different. And now you can guess what the answer should be for equivalent spring constant. When springs are in parallel, the equivalent spring constant will be just K1 plus K2. Just like resistors in series. So if you have 1, 2, 3, 4, 5, 6, 10 springs, one beside the other, if you pull all of them together, everybody will have same extension, forces will be different, the total spring constant will be K1 plus K2 plus K3 plus K4 till K10. That's all. So Pratan, there is a link in the description box. Click on the link for joining vPro, and on the top left corner you have an option to change the course. Just choose JEE 2022 crash course. That's it. That's the easiest way to enroll into the crash course. Perfecto. Parthan, just leave a comment after the video ends. I will ping you the link, and if you want, ping me on Instagram. I'll help you out with it. Okay, so it's very easy. Okay, I'll help you enroll. Don't worry. Okay, just ping me on Instagram. My Instagram handle is right over here, Shreyas_Vedantu. Let's see how many of you can solve this question. Two springs and a block systems are connected as shown. Find the time period of small oscillation. Yes, Mangalam, definitely you can watch. Hi Ketan, good evening Bachalo. So let's see. Ganesh, I am from Bangalore right now, but वैसे तो I am from Pune. So two springs and a block are connected as shown. So what do you think is the time period of small oscillations? First of all, figure out, is this system is in series or is it in parallel? Well, I'll tell you what. See, a lot of you might think that this spring is after the other spring, so maybe it is in series. But let me give you a different perspective. Let's say I move this block slightly over here, okay, slightly over here. So obviously this spring will get compressed and that spring will get elongated. Now if I ask you, where are the spring forces? So if you have moved this block over here, okay, this is the displacement. What are the spring forces going to look like? This spring is compressed, so it will push like this, F1. This spring is elongated, so it will pull like this, F2. Both the forces are in the same direction, not opposite direction. A lot of people think the forces are in the opposite direction, but no, this is compressed on this side, so it pushes there. That is elongated on the other side, so it again pushes it on that side only. Now, look at this system. Imagine there is a spring here of K1 and there is a spring here of K2. And this is connected to a block which has been pushed this side. Now if I ask you, if this system is pushing this two springs on the left side, how will the spring forces look like? Because both the springs are compressed, there will be a spring force like this and a spring force like this over here. Do you find any difference in these two? Do you find any difference in these two? Do you see that the forces are exactly the same as that of in this system? So actually speaking, what are these two springs in? They are actually in basically parallel. So what have I done? I just moved or displaced or disturbed the system. I saw how the forces are. I saw this spring pushes this way, that spring also applies the force this way. Then I thought, oh, both the forces are in the same way, so might as well draw both the springs on the same side, and when you move the block this way, the forces will anyways come and help each other. So basically the forces are assisting each other and they are in parallel, and hence that means the equivalent spring constant. So basically in parallel, the K equivalent will be K1 plus K2. So the time period will be 2 pi under root m by K equivalent, which is K1 plus K2, and if both of them are equal, it will be nothing but 2K. So what option would be correct? Ganesh, have finished center of mass long time back. Beast, this is an English channel, bacha. Yeah, so we'll be talking only in English. Yes, so K equivalent, so that's basically 2K. Perfect. Option A. No, not option B, Lalitesh, be careful. K will be not K, it will be K1 plus K2. So if both the spring constants are equal, yeah. So option A. Yeah, I hope you guys got it. Thank you, Pink Hilden. Thank you so much. Thank you so much for that lovely comment. Okay, moving on to this question. Let's see how many of you can get this. Two springs are here and the third spring is here. So this is K1, this is K1, this is K2. What would be the equivalent spring constant? Let's see how to do this. Well. First of all, can you observe that these two springs are one beside the other? That means they are in parallel. And when in parallel, what happens? It's just like solving equivalent resistance problems. So if they are in parallel, the K equivalent will be, K1 plus K2. Remember, for parallel, you just add. Now, when these two are in series, you can see this one and this one. These both are in series. So the total equivalent, let's say I call it K. How will I find that? 1 by K will be 1 by K1 plus K2 plus 1 by that. Oh, sorry, this was not K1 plus K2, this was I think 1 by K1 plus K1. Yes, so it will be K1 plus, sorry, this was K1 plus K1, guys. So sorry, this both were K1s. Okay, so this was also K1. This is K1, this is K1. So actually speaking, then it will become 2K1. So how about just putting over here? How about just putting over here 2 times of K1 and here that another spring constant which is K2. So that's our equivalent spring constant. And if I flip it, so K will be just 1 by 2 K1 plus 1 by K2, the whole thing inverted. I just flipped it. So hence 2K1 plus K2, I think that's option B. Yep, Roshni, that is option B. Perfect. Got it. Excellent. So that's the answer. Do not forget to flip it. That's the most important thing. Yeah, if you do not forget, if you forget that, then you'll get the exact reciprocal of the answer. Thank you, Subramaniam. Thank you so much. Yes, Chandan, looks like you got it, Ganesh. Very good, Harida. Moving on to the next question. Here it is. There is a spring. It has a certain mass. It's suspended from it, and the period for vertical oscillation is T. Now the spring is cut into 2 equal halves, and the same mass is now suspended from one of the halves. What will be the new time period for oscillation? I'll tell you what this question actually means. You have a spring mass system. Okay, this is K, this is M. The time period was 2 pi under root M by K. We all know that. Okay, time period for a spring mass system is 2 pi under root M by K. Now you cut the spring into 2 smaller halves. That means like this. So this spring which was there, I have broken it down into this and this. The original spring constant was K. Each of them will have new constant K1 and K1. You take that chota spring, that smaller spring, and you just put it over here. Now this will have spring constant K1, you take it, attach it to the same mass. It will have some new time period which will be 2 pi under root M by K1. Question is, how much is this new time period? Okay, let's find this out. First of all, when you cut a spring into 2 parts, don't you see, actually speaking, if you do the exact reverse process, you add these 2 springs one after the other, you get this new spring constant. That means, can I say these 2 are actually in series and this one out here is basically the equivalent. This is nothing but the equivalent. So these 2 are in series and that is the equivalent. So do I know the formula for springs in series? They're equivalent? Definitely. I think I know it. So 1 by K1 plus 1 by K1 is equal to 1 by K. So 2 by K1 is equal to 1 by K. Therefore, 2 times of K is equal to K1. K1 is there. 2 times of K is K1. That's it. Cross multiply. Oh, now I can just substitute it here. So let's see, what do I get? 2 pi under root M by 2K. Wait a minute. I already know 2 pi under root M by K is time period. This extra 2 is there. So this is just T by root 2. That's it, right? So it is just this 2 pi M by K, that's time period. So only that root 2 is extra. So I think I got it. So the time period new one will be T by root 2. That's the answer. Perfect. Yes, Chandan, they are in series. Thank you, Ganesh. Looks like a lot of students are there from Pondicherry, Chennai and Tamil Nadu. And a lot of, yeah, the southern part of country. Very good, very good. So, sir, in SHM we can use torque equation for solving? Yes, we are going to do that in angular SHM. So we are going to study angular SHM, simple pendulums. We are going to study torque and SHM as well, definitely. Moving on to the next one, but before we go ahead, let me also tell you, if you want all the important updates, notifications, PDFs, everything, that one thing which you should be enrolled into is our Telegram channel. The link is there in the description box. Make sure you join it to get all the resource materials of this channel, including the updates. Now, oh, Abhi, you're from Kerala. Wow, very good. welcome, welcome. Very close to wherever I am. Beautiful, beautiful state. Let's talk about different ways, like I said before, of proving or finding the time period of SHM. See, what are the different things that you have learned till now? One thing you learned that if it's a SHM, then the motion will be something like this. X is equal to a sine omega t plus phi. So if somebody tells you, x is 7 sine 100 t plus pi by 3. Is this SHM? Yes, definitely this is SHM. You know it. Okay, fair enough. Is there any other way that I can know it is SHM? Yes, I think I know. Acceleration is negative. So for acceleration is minus omega square x. If somebody tells you acceleration of a particle is minus 100x, is this SHM? Yes, definitely. Because acceleration is proportional to x and it is opposite to x. Definitely it is SHM. Okay, great. I think even when, see, if acceleration is proportional to x, even force can be proportional to x, right? So if F is minus kx, so for force, okay, even then the system is going to have a periodic property in its motion. So imagine there is a mass, okay, imagine there is a mass, and I tell you the force on it is minus 8x. Well, if it moves by x, the force is minus 8x. So yes, it's going to oscillate, and I know the value of k is 8. So I can find the time period. Very good. So that's one other thing. There are even more ways, like differential equation. Remember the differential equation? I just gave it to you. So if somebody tells you the differential equation is m second derivative of x with respect to time plus kx is equal to 0. So something like this, like 7x, or 3 second derivative of x with respect to time plus 6x is equal to 0. Is this SHM? Yes, definitely it is. I can find the time period. You can see this is nothing but m, this is comparable to k. Once you know m and k, you can find the time period. So all these are different ways of proving or finding the time period of SHM. Are you able to see that? Yep, everyone? Perfecto. Can we express SHM in terms of cos? Yes, definitely you can. And that's what you will see in the next class when we are going to talk about phasors and phasor diagrams. It doesn't really matter whether it is sine or cosine. So I can probably add over here or a cos omega t plus phi. Now I have one question for you. Do you think if I add one term over here, let's say plus some constant, do you think it will still remain SHM or now it will not remain SHM? There is some constant over here. Think. If there is some constant, a sine omega t plus phi plus some constant, what do you think? Will it still remain a SHM? Or do you think it will not remain a SHM? Okay. Chandan, you are 11th or 12th standard students. Oh, you guys, all of you have 11th standard midterm examination. Prabhu, kaise ho, kitte ho? Changa, sab badhiya. I hope, I was able to speak a little bit of Punjabi. I don't know too much of Punjabi, but alright. Okay. What do you think? If I add some constant? Well, it doesn't matter. It's just shift of origin. So it doesn't matter. So it's like a particle is performing SHM. Now if you add some plus c, it's just that you're shifting the origin. So just adding a constant really doesn't change anything. So even over here, by the way, let me tell you, if you just add some constant over here, plus, I don't know, some constant. This constant is just a constant force. It will not affect anything. It's like constant mg force. Imagine, you have a spring and a mass. So gravity is a constant force. Fine, that is there. That's always going to be there. The spring is going to act like that restoring oscillating force. So a constant force or a constant term over here really does not affect anything. It will still remain, a SHM. Remember that. So all these are important things. All these are important things. Moving on to the next one. Okay, let's start solving some questions. So we have a particle. Oh, Lalitesh, you have term 1 at the end of December. Okay, interesting. Okay. A particle of mass 2.5 kg is released from rest at x equals to 3 meters under the force F is equal to minus 10x plus 20. Find the equation of motion of that particle. Let's try to do this. Rohit, as such, you will not need it until angular SHM. So only in that part you will need little bit knowledge of moment of inertia and torque, but apart from that you don't need rotational motion. Yes, circular motion will be needed for angular velocity and all of that. Okay, so let's try to solve this. If you compare this with F is equal to minus kx plus some constant, quickly you will understand k is nothing but 10. Okay, so k is nothing but 10 Newton per meter. Fair enough. If you take that particle of mass 2.5 kg, so mass is also known 2.5 kg. So from this you can quickly find omega, which is root of k over m. So k is 10, mass is 2.5, so that is root of 4, which is nothing but 2 radians per second. That's nothing but omega. Why do I need this? Because I have to find the equation of motion of particle. What is the equation of a motion of a SHM? X is a sine omega t plus phi. That's the equation of motion of a particle performing SHM. What and all do I know till now? I just have found out omega. Do you see that? Omega is known, amplitude is not known, phi is not known. So let's draw the diagram. So imagine this. This is your line of SHM. This is x equals to 0. At t is equal to 0, you are releasing it. You are releasing that block from x is equal to 3. You are releasing the block. So Abhi, why doesn't gravity affect the time period? If you want, I will do a detailed discussion in one of the other classes. But yes, what happens is the constant force, is not proportional to x. So whenever you have SHM, the force should be proportional to x to cause that oscillation. So constant force will only accelerate it continuously. It will not, make it come back and then oscillate. So that's why a constant force never affects the time period of oscillation. Okay, it's just there always in that direction. It's just going to shift the block over there, but it's not going to affect the time period. Okay, anyways, now if you release this block from x is equal to 3, if you release it from here, then that means it will start performing SHM from there, and that would obviously be the extreme position, correct? It's stretched already, you leave it, its extreme position, it starts its journey, it reaches here and then again reaches here at x equals to minus 3, which is the other extreme position. So guys, quickly tell me, what's the amplitude? What do you think? What's the amplitude of this oscillation? I think I just found it out from here. So the amplitude of the oscillation is nothing but 3 meters. That's what I got. So this is also found out. The only thing remaining now is the value of phi. So think about it. At time 0, x is equal to 3. So just substitute it. Over here. So at t is equal to 0, x is equal to 3 in the equation. So x is equal to 3, a is equal to 3, I just got it, sine, time is 0 plus phi. 3 cancels, so I'll just get sine phi is equal to 1, so phi is 90 degrees. Everything is got, everything has been obtained. So what's the final answer? X will be equal to amplitude sine omega, which is 2, into t plus pi by 2. That is our final equation. See if you guys got it. See if you understood it. What a beautiful question. You were given force, you are given mass, you are given the initial condition. From that you are able to one by one dissect the problem and get to the final conclusion. Beautiful. Yes, sir, this is more than enough for NEET. Okay, so we have another equation, but I think many things were unnecessary over here. So this was a part of a big question, so I just want to solve the smaller part of it. I just want not the angular velocity, I just want, okay, and this is not two SHMs, it's just one SHM. So find the time period of this SHM given by this differential equation. Differential equation is given. So how does our general differential equation for SHM look like? Try and recollect. It looks something like this. M d square x by dt square is plus kx is equal to 0. Now just compare both of them, you will get the answer quickly. So what is M? What is the coefficient of this? Quickly, what is there? D square x by dt square. The coefficient is nothing, 1. Okay. What is k? K is nothing but 9 pi square. What is the question? Find the time period. So time period will be 2 pi under root m by k. So the mass is 1, k is 9 pi square. Pi square's root is pi, pi goes. So 2 by root of 9 is 3. So 2 by 3 seconds. That's the answer. Very good. So I'm telling you, SHM is actually easy. If you are fast with calculations or even decently good with calculations and maths, you will get it. Definitely. 6 pi square. No, it is not 6, it's 9. Okay, this is 9 pi square. Okay, so no, that's not the answer. 2 pi under root m by k. I think you made a mistake and probably copying it down or probably seeing it. So k is 9 pi square. You can see that. M is 1. So ignore this. So m is basically 1. Okay, Roshni, is that fine? All right, cool. Moving on to the next question. Which of the following functions represent simple harmonic motion? Very, very interesting question. Only one of, no, more than one could be correct. Which of the following can represent SHM? Yeah. Now this is very interesting. Yes, thank you, Abhi, for all the love. Now, many of you are going to feel, sir, I don't think any of them are SHM. Well, I'll tell you, some of them are easily eliminated. You can see sine omega t, sine 2 omega t. Remember, day 1 I had told, if you have terms like sine omega 1 something, sine plus sine omega 2 something plus these things, it is harmonic motion, but definitely it is not SHM. In SHM, you should have only one term. Now clearly you can see sine omega t plus sine 2 omega. So omega 1, omega 2. So omegas are different. So definitely it is not SHM. In fact, it is just harmonic motion. Same is applicable for option D. That is also not SHM because you have omega 1, omega 2. So that is also basically just harmonic motion, not simple harmonic motion. Oh, 2 pi root k by m. That's a common mistake. Be careful. Yes. A lot of students do that. Okay. Don't worry, you'll get it with practice. Happens. Now, sine omega t minus cos omega t. You will be like, sir, even in this there are two terms. Even in, this is a sine square, sir. So this is definitely not SHM. None of them are SHMs. But I'll tell you what. Let's try to manipulate it. This expression, let me just manipulate it like this. Multiplied by root 2 and divided by root 2, there is a common form which is a sine theta plus b cos theta. What you do is multiply and divide by root of a square plus b square and you get it in a good looking form. And here I'm going to do the same thing. Here a is 1, b is 1, 1 square plus 1 square is 2 square. Sorry, 1 square plus 1 square is 2, root of 2. So let's just multiply by root 2 and divide by root 2. So I'll get sine omega t into 1 by root 2 minus cos omega t into 1 by root 2. You're wondering, what am I trying to achieve? Because anyways, root 2 just got cancelled. If you open up the brackets, of course. What's exactly happening? Let's just find this out. It's a very interesting trigonometric trick. Probably you would have learned this in maths, especially for all the questions which are of the form a sine theta plus b cos theta. When you multiply it by root of a square plus b square, it can be combined into one single sine or cosine term. Observe, if I write this as like this, sine omega t, what is root 1 by root 2? It is sine of 45 degrees, right? So sine of pi by 4 minus cos omega t. What is 1 by root 2? It's cos of 45 degrees. Now comes the interesting part. Sine A sine B minus cos A cos B. What is it? What is sine A sine B minus cos A cos B? Come on, my warriors. Hi, Susan. What is sine A sine B minus cos A cos B? What is it? It's a cos equation. It's a cos equation, correct? Sine A plus B? Oh, no, it's not sine A plus B. It is cos A plus B. Yes, it is cos omega t plus pi by 4, but you can actually take that minus sign outside, okay? Because it's cos A cos B minus sine A sine B. Yep. Okay. If you want, you can also, let me tell you, you can also do one more thing. If you don't want this sine and sine, and you can also write it as cos, and here you can write it as sine. It still works. And sine A cos B minus cos A sine B will be still, you know, sine of A minus B. So cos of omega t minus pi by 4. It still works, correct? It's one and the same thing. Do you see I have narrowed it down to one single sine term? I have narrowed it down to one single sine term. So the moment I can narrow it down to one single sine term, that means it is definitely a SHM. So that's it. Option A is correct. Perfect. Got it? So that's what you got. Now, if option A is SHM, what about option C? What about option C? Guess what? If you look at option C, sine square omega t, I can do some magic. Remember, there is a formula for cos 2 theta. And it is nothing but 1 minus 2 sine square theta. So if you shift 2 sine square theta here and cos 2 theta there, so you will get 2 sine square theta is equal to 1 plus cos 2 theta. And if you shift the 2 below, so sine square theta is 1 by 2 plus 1 by 2 cos 2 theta. Using this formula, you can see sine square omega t is nothing but half plus half. Instead of sine omega t, you have cos 2 theta. So cos 2 times omega t. Now what is this? This is some constant plus amplitude into cosine, and you have angular frequency into time. Constant doesn't matter. Amplitude into cos term, definitely it is a SHM. So even this is a SHM. This is a SHM. Got it? Got it? Understood, everyone? So very tricky question. A lot of students are going to make mistakes. They are going to think instantaneously, oh, this is not SHM, this is not SHM. But actually, if you modify, it can be combined into one term. This can be also written down as one cosine or sine term. Constant does not matter. The next class will be tomorrow. Okay? Yes, Rohit. The next class is going to be tomorrow. Perfect. Now, yeah, there are 3 homework questions or 2 homework questions. I'll show these to you. This is the first homework question. Put up the answers in the comment section. This is the second homework question. Put up the answers in the again in the comment section. I'm going to show and read all the names in the next class like I did in this class today. And this is your third homework question. Very easy. I'm pretty sure you'll be able to do this. And do not forget, if you want to enroll into my courses, if you want the crash course, if you want the 11th standard, 12th standard crash course, it's all there in the video right now, whichever you are watching. All you need to do is go down. You can see JEE 2 years crash course or JEE 2 years subscription. If you want, you can even change this. You can choose which grade you are in. If you are in 11th or 12th, let's say if you are in 12th and your target exam is crash course, you can choose that. The crash course is available for 12th standard for 9,000 rupees. Okay, you can see that. Similarly, if you are a 11th standard student, okay, so let's say you choose 11th standard and grade 11th, you can see JEE 2021-2023. KVPY crash courses, recorded classes are also there. You can see that. So if you want the KVPY crash course, guess what? It is just for 1,800 rupees. It has all the test series, assignments, recorded video lectures and assignments for your 9th January KVPY exam. Not just that, if you want, you can just go ahead and choose the long-term batch. So when you choose this, where is this? Grade 11, then you get everything. KVPY, you get Olympiads, you get the JEE Mains, you get CBSE, everything for a price of 1,350 rupees per month. So that's when you have applied my coupon code. You can try it for 15 days. You can also buy the complete course if you are fully satisfied. Yes, I want to go with Shreyas sir. That's it. Go ahead with the complete course. But yes, I would suggest you can try it out for 15 days and then continue your journey. You get personal mentorship in the plus version. In the classic version, you get additionally the doubt solving. But in the light version, you get live classes, you get recordings, you get notes, you get assignments, you get test series, you get PDFs, you get report cards, you get parent-teacher meets, you get 2 teachers in the same class. So all of that in our pro subscription courses right at your fingertips. Okay, so this chapter is going to take a couple of lectures more, definitely. And Anga, please let's talk about this. Please connect with me on Instagram or leave a comment after this video ends. This is where you can connect me on Instagram, and I hope you have already hit the subscribe as well as the like button. All the best for your examinations, Tarun, and everyone out here. Please do well and wait for the video which I'm going to put up in some time. Okay, so stay tuned, take care, and I'll see you again tomorrow at 7:30. This was your favorite Cap to Shreyas, and I was going live on Enthuse. See you, bye bye, take care, hasta la vista.